we are back working on Unit 4 review. We're going to do the odds. The first section is asking us to solve for the missing variable. One of the key rules that we're going to use on this section is that when you have a triangle, these two angles opposite that outside angle right there, these two angles add to equal this one. Okay. So what we're going to do is we look here at problem number 1, and you've got angle 70 and angle 88, and the rule is that those two are going to add to equal this outside angle. So 70 plus 88 gives you 158, so y equals 158 degrees. We apply that same concept here to problem number 3. 51 plus this other angle adds to equal the outside angle. So I'm going to set that up in an equation. 51 plus 2x plus 3 equals that 4x plus 8. And then I'm just going to solve by combining like terms. 51 plus 3 is 54, plus 2x equals 4x plus 8. I'm going to move my whole numbers to the left because there's more of them over there. Minus 8. You get 46, and then you subtract those two x's from both sides. 4x minus 2x equals 2x. To solve for x from here, you divide by 2 on both sides. So you get x equals 23. Number 5 is a little bit different because it's an isosceles triangle. What I know about isosceles triangles is if these two sides are congruent, then the opposite angles are congruent. That means I just set them equal to each other and solve. 3x minus 11 is going to be equal to 2x plus 11. I'm going to move my x's to the left. Minus 2x minus 2x. 3x minus 2x is 1x. And then I'm going to move my whole numbers to the right. Plus 11 plus 11. So x is going to equal 22. If you look at now I have to take that x, and I have to go back and plug it in order to solve for my angle so that I can figure out y. 22 times 2 is 44, plus 11 is 55. So this angle is 55, and this angle is 55. Let me make sure I did that right. 2 times 22 is 44, plus 11 is 55. Okay, so you should be good there. You can double check yourself on the other problem as well. 3 times 22 is 66, minus 11 should be 55. So because they equal, I know I did it correctly. And then from there, I know all three angles inside a triangle add to equal 180. So I take that 55 plus the other 55 plus that 2y and set it equal to 180. 55 plus 55 is 110 plus 2y equals 180. In order to solve for y, you're going to subtract 110 from both sides. You get 2y equals 70. From there, I divide by 2 on both sides. Get y equals 35. So x is going to equal 22, and y equals 35. Number 9 tells me that these two angles are congruent. So what I know is that it is an isosceles triangle, because if this angle is equal to this one, then the opposite sides are congruent. So 28 is going to equal that 9x minus 8. I add 8 to both sides. You get 36 equals 9x. To solve for x, you divide by 9. So x is going to equal 4. Number 11, I'm going to apply that same concept. If these two angles are congruent, then the opposite sides are congruent. It's an isosceles triangle. So first I'm going to solve for x, and then I'm going to solve for the perimeter. I know that these two are equal. 2x minus 1 equals x plus 4. To solve for x, you subtract x from both sides. 2x minus x is 1x. Then you would add 1 to both sides and get x equals 5. But I'm not finished because I need to go back and find the perimeter. So I plug in 5 plus 4 is going to equal 9 for this side, 9 for this side, and I know my perimeter means I add all the sides. So 9 plus 7 plus 9 is going to be 25 feet. Problem number 13, 15, 17, and 19 are all talking about congruency statements. If you have triangle X, Y, Z, it's good to always draw a picture, and it tells you XY is going to be congruent to YZ, and angle Y is 52, that vertex angle is 52, then what is angle Z? I know that this is an isosceles triangle, so whatever angle X is, angle Z is that angle as well. So what I'm going to do is I'm going to take 180 minus that vertex angle. 180 minus 52 is 128. And then from there, I take whatever's left and I divide it equally between these two angles. So 128 divided by 2 is going to be 64. I can always go back and double check myself, plug it in here, and see, does 64 plus 64 plus 52 add to equal 180? Yes, it does. So number 13 is 64. Number 15, I'm going to draw a picture again. You've got triangle CAT, and it tells you angles C and A are congruent. CA is 7, AT is 4. What is the length of CT? Well, if angle C and angle A are congruent, then I know the opposite sides are congruent as an isosceles triangle. So AT is going to be equal to CT, which is 4. Okay. CAT, C is equal to A. CA is 7, AT is 4, so CT is also going to be 4. The next one is talking about two triangles. TJM is congruent to PHS. These congruency statements tell us a lot. You want to draw a picture in order to compare the two triangles. TJM is congruent to PHS. And so what that tells me is that TJ is going to be congruent to PH, JM is going to be congruent to HS, and TM is going to be congruent to PS. It also tells me angle T is going to be congruent to angle P, angle J is going to be congruent to angle H, and angle M is going to be congruent to angle S. It tells us a lot just using that one little statement. So what we're going to do is just fill in what we know. JM, this side right here, is going to be equal to this side right here, which is HS. Triangle HPS. So if you start with the H and go to the P, then you want to start your triangle congruency statement with the J, because H is congruent to J. And then going down to P, I would mimic that on my next triangle and go down to T, J, T, and then M at the end. Congruency statements are all about staying in order, so make sure that you stay in order. They tell you a lot. Just a few more problems here. The next section, we were talking about whether or not there's enough information in order to prove these triangles congruent. Number 21, whenever two triangles share the same side, that side is always congruent to itself by the reflexive property. So is there enough information to tell that these two triangles are congruent? Yes, because each side is congruent to the corresponding side of the other triangle. So DS by SSS. And then you want to write your congruency statement, making sure you stay in order. ST is going to be congruent to QT, and then it goes to R. Same with my other triangle, triangle QTR. Notice that S is going to be congruent to Q, T is congruent to T, and R is congruent to R. Making sure you stay in order. Writing corresponding parts of the triangle in order. My next triangle tells me that this angle is congruent to that angle. This side is congruent to that. So just with that information, you cannot say that anything is a right angle on these triangles because it's not given. So you just want to read it. Side, angle, side. Yes, there's enough information. The angle that's congruent is right in the middle of the two sides. That's how I know it's side, angle, side. Then I want to write my congruency statement. Triangle ADK, if you start with the A on this triangle, then I want to start with this T on my new triangle. It goes from A up to D, and so I want to take from T up to S, and then down to K, making sure I stay in the same order from one triangle to the next. The next section is similar. It's asking for us to look at the congruency theorem that they want us to use to prove these triangles congruent, and then say what additional piece of information we need in order to prove them congruent. So we've got two triangles, DEF and QRT. DEF, QRT. So given the angle E is congruent to angle R, and EF, this side, is congruent to RT, this side, what additional information do I need to prove angle, side, angle? Notice, I already have an angle and I already have a side. And so that next piece is this last angle. Angle, side, angle. I need this one, angle F, congruent to this one, angle T. So it reads angle, side, angle. Angle F congruent to angle T. Then it's asking for how to prove an SSS. Well, it tells me DE is going to be congruent to QR. I'm just going to use a different color here so I know I'm working a different problem. DE is congruent to QR. FD is congruent to TQ. So what other side am I missing? Well, on my problem with the yellow marker, I'm missing this side right here, congruent to this side. So I just want to write that. Side FE, it needs to be congruent to side TR in order to prove by SSS. That's it for Unit 4. Hopefully that helps you guys out. If you have any other questions, please come see one of the geometry teachers before your final. Thanks and have a good day.